Okay, I want to point out we derived this identity, which took a rather lengthy sum and wrote down a very compact statement over here, 1 minus cosine 2n theta, all right? What they want to do for letter A is, first of all, read and understand what I'm reading. It says let an be an approximation of the area under the curve, y equals sine x from x equals 0 to x equals pi, using n rectangular strips, each of which is pi over n. Okay, this is going to be a Riemann sum, equal partition. However, the sample point, not going to be the left or right, it's going to be the midpoint, all right? Top of each strip of the curve. All right, so what I got to do is hopefully I'm going to see this thing here when I put an down. All right, let me go through that. And before I do anything, I want to point out what we're doing over here. We're taking the sine curve. It looks like this. And that's between 0 and pi. And we're dividing into n equal partitions. And if you're doing n equal partitions, each partition would have a base size of pi over n. But we're using midpoints. All right, we're using midpoints. So basically, I'm just going to write down what an is now. So what's an going to be? I'm using midpoints. So I mean, the first partition, there'll be a midpoint over there. And the midpoint formula, you might have to rederive it. It comes from Calc 1, or just simply, if you remember it, that's great. If you have to rederive it, that's good too. I'm just going to write down what it is. Okay, so it's going to be pi over n times the sum I equals 0 up to n minus 1. And then it can be sine. I'll write this down now. And what you do is you're really taking the first value over here, which is going to be pi over 2n, plus you got to keep moving up the length of that base, which is pi over ni. All right? That's pretty compact, by the way. Of course, what I'm going to do now is just maybe rewrite a little tiny bit. I certainly don't see what I need to see at this point, but I'm getting closer. I certainly know it's a sum. And when you get there, sine, I'm going to do a common denominator now. It's going to be 2n, and then you get pi plus, let's see, that would be 2 pi I now, right? Okay, I got that covered. Now what I'm going to do is I'm going to expand it out and see what I see. And what I see pi over n times sine. Well, if I is 0, I just get pi over 2n plus sine. If pi is 1, I would get 3 pi over 2n. This is kind of what I'm expecting to see, by the way. I'm expecting to see odd multiples, just like from that formula that we did. Plus, yada, yada, yada. All right, here comes the tough part, sine. I'm going to do some side work over here. And when I do that, I'm going to put down pi plus 2 pi. And now we're going to stop at n minus 1 over 2n. And what's that going to give you? Got to be careful here. It's going to be pi. Pull that out. It's going to be 1 plus, I'm pulling pi out, 2n minus 2 over 2n. So I'm going to look at that and say, let's take a look at that. You definitely get pi over 2n. I see that. What's the multiple, though? It's 2n minus 1. All right? That's what I was kind of expecting, by the way. 2n minus 1. So, let's see what we got over here. I'm going to write this down now. By the way, this is an. I am now going to write down what they're basically what I see in the question. An times sine of pi over 2n. Well, What's that going to be? Let's think about that. AN times sine of pi over 2n. Let me write this down. So pi over n, I see that there. Then I write down sine pi over 2n times sine pi over 2n plus sine 3 pi over 2n plus yada 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 plus sine 2n minus 1 times pi over 2n. All right? And I think I recognize that formula, right? Formula we just did. All right, let's write that down now. So what do you get here? You get pi. Gotta be careful here now too. I can look back at that formula and see if I have what I want. I'm missing a 2. I gotta put it in. Because I see it in the formula, right? And now I'm seeing this over here. And what do you see? Pi over 2n. And this is going to equal 1 minus cosine. Again, I'm looking back at the formula. It's going to be 2n times whatever the angle is. This is the angle, pi over 2n. All right, I'm getting close now. And we'll go back to the notes in a second because this is supposed to be equal to something. I'm going to look back over the notes and see what this is going to be. This is going to be 1 minus the cosine. Well, the 2n's cancel off. I just get pi, right? What's cosine of pi is minus 1. So we get pi, 2n, and then we get 1 minus minus 1, which is 1 plus 1. And if you simplify this, you get 2, and the 2's cancel, and you get pi over n. Is that what they asked me to show? It is. So it's QED now. And we're done. Thank you.